So without further ado, allow me to introduce our very first speaker for the Tech Stack Forum, Chad Arimura, co-founder and CEO of Iron.io. Chad is a serial entrepreneur and at heart a technologist, evangelist, and engineering leader, really passionate about building the best cloud infrastructure that's out there. And when Chad isn't busy ringing the bell about the oncoming microservices revolution, he spends his time, and I'm quoting from your official bio here, rocking out with a San Francisco cover band, playing indoor soccer, and this third one is my personal favorite, hyping up cloud computing with random people who may or may not care. It's brave work, Chad, and we thank you for it. So we can turn it over to you.
Check, check. All right, thanks. So where did you pull that bio from? Kind of playing a band still, but thanks, Shruti and Bloomberg for hosting and putting on this event. Just to thank you, I'm totally going to bait and switch my talk a little bit today. My normal talk is on microservices, and I did say I was going to talk about monoliths and microservices. I will cover some of this today, but I only have 20 minutes, and there's not a whole lot you can do to cover microservices in 20 minutes. You can find everything you need to find on the web about the architecture, how to get there. There's so many interesting things to know about it. And I believe that microservices are a fundamental building block for where we're going in the world. It's a fundamental architecture that I'll talk about briefly today. But my talk today is going to be a little bit more abstract. Let's go on a little vision quest, per se, about where we think the world is going and sort of what the end goal is with a lot of these architectures. And so we call it serverless architectures. Who in the room has heard of the term serverless architecture? Okay, cool. Serverless architectures are, it doesn't mean there's no servers. Okay, there are still servers. It's the concept of not having to think about them. And it's a buzzword now. This year, it's kind of this meteoric rise buzzword. And rather than telling you that we're jumping on the buzzword train, which we kind of are, but we have been talking about this since 2012. We started the company in 2011 on the promise of building a developer platform that developers could stop thinking about all the plumbing and the hard stuff that's underneath. And I think that there's a lot of technologies that enable that today, and we're advancing very quickly in the world. In 2012, we wrote an article called The Future of Software and Apps is Serverless. Absolutely destroyed in the comment thread. If you look, people did not like the article at the time. It turns out that they are starting to sort of see the kind of things we were talking about. Our founding partner, Ken Fromm, wrote this. So we have some proof. The agenda today, real quickly, I've got about 20 minutes. Give me a holler when we're getting close to it. I am going to talk about some Legos. I promise I'll talk about those. I will propose a manifesto for what a serverless architecture looks like. And then we'll talk a little bit about the future, because I do believe we have some intuitive ideas of where the world is going, but I'd like to narrow that in and sort of give our perspective on what we're seeing with our customers. Okay, does anyone know what the space mineral detector is and what it has to do with serverless? Okay, that's a trick question because nobody does. This is something, when I say we, I'm collectively saying myself, because I'm 36 now, and everyone plus or minus 10 years probably knows what Legos are, right? We played, we learned, we built everything using Legos growing up. This is a space mineral detector. I had probably all 6,000 sets of Legos. I lived in these things. I had blocks, everything, right? That's how I learned to build things as a kid. This, sorry for the language there. This is a TI-83. This is how I learned to program and architect software when I was a kid. I learned to hack drug wars so that I could win the game faster and not have to play for hours and hours and hours. But you have to get in, and it's literally basic. The language is basic, and that's how you write these games on the TI-83. This is a MS-DOS prompt. Thank you for the segue. You totally blew my hypothesis, though, about this talk. This is how I had to configure my terminal in order to play the games I wanted to play as a kid. Right? I had to get into config.sys and change the no EMS. I had no idea what the hell I was doing, but my dad would say, try it. Voila, the game worked. I don't know, files equals 50? What does that even mean, right? But that was what I had to do as a child to learn to play games. This is how I learned to build and consume technology. This is how I learned to build websites before websites existed. This is a 14.4 baud modem. This is how we connected with the world. This is Renegade BBS. I spent years configuring bulletin boards and connecting. I had 3 phone lines that came into my room, and people, they would light up and they would jump on, and I would talk with them. I would give them access to the hidden materials, after calling them. That's how I learned to connect and build. And I think collectively in this room, these are the things, the technologies that we had growing up and learning. And this is how we learned to connect with others. We plugged our computers in and we played Warcraft. We played Command and Conquer, right? We had a 5-port hub. We plugged them in. We'd carry our physical computers over, put them in a room, we'd play games. And this is how we learned to consume. I had a Walkman. I carried around. I had 13 songs that start to sound funky. You flip the tape into 13 more songs. And this is how I learned to consume information, right? I was building and connecting and consuming using these types of things. Right? This is the encyclopedia. My dad was really proud of his set. It was highlights and underlines and all sorts of great things going on. Everything I ever needed to know was in these books. That's how I learned. So when I say collectively, we learned to build, connect, and consume with a deep connection to the physical world. If you start to see the theme, we had a deep connection to everything in the physical world. That was how we learned. That was how we grew up. That was how we learned to build, connect, and consume. But now let's contrast that to today. Everybody has seen this. If you have kids, they're locked into this Minecraft. It is unbelievable. I don't even understand the point of it. But I guess, you've got yeah, that's right. I just don't understand it. But you got a pig. You can kill the pig if you're in the war mode or whatever. It's thousands of worlds. Or you can download any world. This is the equivalent of the space mine detector, right? This is like a space station that you can build virtually. If you imagine it, it's there. You didn't have to go to Toys R Us and dark, lit, creepy rooms and buy the Legos. Unlimited download. This is a 0.086 version of a Battlestar. And this, you talked about, you didn't talk about Scratch, but I'm going to talk about Scratch. This is how they're learning to build today. This is called Scratch. What I found most interesting about Scratch, it's a little if-then statements to build software, and you can make things move around and dance, and the kids are building the most unbelievable things these days. This actually, I don't know if this is actually related, but there's such a correlation to GitHub. In the way that developers today are building software using GitHub, we've got view source, we've got forks. You can't see it down here, but they're called remixes. You've got stars and hearts and shares and forks, and it's incredible the parallel to how software developers today are building software. This is how the kids are learning. Now, a couple more. This is how they're learning to connect, right? Unlimited connections with anybody at your disposal. This is how they're learning to play and connect and consume with others, right? This is World of Warcraft. It's actually it's interesting. Warcraft, World of Warcraft. It's changed. And this is how they're learning to consume today. I learned how to tie a bow tie from my dad. Now there's 1.7 million dads teaching you how to tie a bow tie. And you never need anybody. You've got unlimited stuff. This is my favorite one, the last slide on this little rant. This is how they're learning to consume today. Everything that you ever need to consume in one place at your fingertips. You want to watch a movie, you buy it. You want to listen to music, you stream it. You want to order food from Grubhub, you order it off this, they come to your door and they deliver it to you. It's a totally different world. Our children and our nieces and our nephews are growing up. They are learning to build, connect, and consume through a loose connection with a digital world. There's no more physical world that there's a deep connection to. My niece, she's 7 now. She has a iPod Touch. She plays this thing all day long. And then one day she broke it, and she has so many games. She broke it. She cried. They call up Uncle Chad. We send him a new one, and boom, she's gone. And the next day, didn't miss a beat. She's sharing and playing her games. She doesn't even understand that the iPod Touch was actually this gateway to everything behind it. It's just this device that gets her games to her. There's no connection. There's no config.sys. There's no, you talked about terminal, and that's amazing that they're using grep. But you don't need to know that stuff anymore. So we talk about serverless. And a gentleman, Peter Wagner, and someone at Wing VC, I'm sure many of you know him, he talked about the digital dialectic. And I think there's a parallel here to this concept of serverless. The digital dialectic, he states, and I really believe that physics has really driven hardware changes over time, but software architecture has sort of emerged out of the improvements in the infrastructure or the hardware infrastructure. So obviously we build mainframes, and then we have monoliths that go on those mainframes because we have one stack that fits on one computer, and that's how we scale. Scale, you scale up. But then we get open systems in the early 90s, and we have an explosion of client-server. The software architecture follows the hardware infrastructure, and then they drive each other in a dialectic cycle. So if you fast forward now, we're starting to talk about virtualization, or we've been talking about virtualization in cloud. So we've now abstracted out the hardware from the software. We have this layer called the hypervisor, and that emerged cloud. Cloud is API-driven hardware. We're driving hardware with software now. And out of that, which my talk was supposed to be about, so I do mention it, we've got microservices. Now, microservices are API-driven, single-purpose units of function that we pull out of monoliths, and they're small, lightweight bits of code that are scaled horizontally. You've got an API in, and all you really need to know is how to communicate with the API. You don't need to know the internals of the app. You can upgrade it on the fly. You have small teams. All sorts of great things about microservices. Driven out of the virtualization and cloud, emergence of virtualization and cloud. So Peter goes on to talk about it, and this is where it gets really interesting. Now we've got this concept called containers. And everybody's probably heard of containers now. It's like, you know, the cat's meow. Containers, what he makes this argument, and this is not original for me, but this is really fascinating. This is a picture of the Ideal X. The Ideal X in 1950-something was the first ship to take physical containers across the ocean. And out of that, we started creating fleets that would transport containers. We started standardizing on the way we shipped containers. We started standardizing on the way that they were received at ports. So the lifts and the arms were standardized. Then the trucks became standard. Then the trains became standard. And now we have software and sensors that are now standards for moving physical goods around. And an explosion of distribution happened in the world. We're seeing a similar pattern now with a standardization around containers, because containers gives a standard way to make software portable where you don't really need to know the underlying infrastructure. Now we've got almost complete abstraction away from the underlying infrastructure. So that's a step. So those things in microservices really tie very nicely together because we have lightweight, portable microservices that can be deployed anywhere. And so my hypothesis is that if you were to extend this line, what we're looking at, the ultimate goal is a serverless architecture. Now, call it what you want. Maybe serverless is stupid because there's still servers. I don't know. It's buzzwordy. But the concept is that our children, our nieces and our nephews, the next generation of developers, and the architects today need to start thinking about how to architect systems for your future developers to build software where they're not thinking about all the stuff from the past. That's the key. We have to start thinking about how to architect our systems so that we're abstracting this away. And this is happening today as we see it. And so a definition of serverless, it's really the concept of architecting software that follows these learnings, and it shifts the thinking away from the physical world. Because I think if you think about the way we learned, we build, connect, and consume, and we think about the history, the architecture, evolution, we're going to start to see this shift away from thinking about these things. So I have a few minutes left to talk about a manifesto. I won't have time for a demo. We'll talk a little bit about architectures. But if you haven't seen this, this is called the Reactive Manifesto. This is built by the folks at Lightbend. It's a manifesto about how to build reactive applications, which are scalable, distributed. It's a set of common terms that we can use to describe architecture of modern applications. This is great. If you haven't seen it, check it out. Responsive, the properties of reactive are responsive, that you respond as quickly as possible because people care about latency. Resilient, that under failure, you can continue to respond as quickly as possible. It's elastic, meaning you respond to load and you can maintain resiliency and responsiveness based on elasticity, so you can scale architecture horizontally. And it's message-driven, meaning you decouple elements of your system using message queues and message buses so that failures in one system don't trigger over failures in other systems. Now I'm going to steal this, and I'm going to implement, and I'm going to extend it into what we call the Serverless Manifesto. It's a work in progress. Feel free to comment. Serverless applications tend to be event-driven, meaning an event comes in, it spawns a reaction from the application. The application responds with infrastructure capacity growing behind the scenes. That capacity goes away once the event is processed. That's the concept of event-driven. An event can be, actually, I'll go through the list real quick. Containerized, composable, and workload aware, if you can't see it. So as I mentioned, event-driven is a fire and forget model, meaning an event triggers the invocation of a function, a task, a worker, an app. Call it what you want. It's an evented architecture. We're starting to see these patterns in our customers today who are pushing towards these models. Containerized, I talked briefly about containers, but I think that there's going to be a lot of innovation in the container world, whether you're using CoreOS or Docker, or you're basing containers on Alpine Linux. They should be small and lightweight because we're pushing a lot of network traffic around now. We're spinning up and spinning down applications on demand, so they need to be small and lightweight. That's something that we call microcontainers. And it becomes ultra portable and abstraction. So these are key sort of fundamentals to building these architectures. Composable is an interesting one. I mean, this has been a term that's been used for 20, 25, 30 years about software, right? We're seeing the reemergence of, obviously, SOA, which has a really sort of negative connotation these days. But SOA, the promise of SOA was really strong. I spent 3 years at Oracle, and I bought into the Kool-Aid. SOA is pretty amazing conceptually. But now we've got distributed SOA. We've got composable applications. We've got a million services to choose from. If you want search, use Algorithmia. If you want image processing, use Cloudinary. You can just plug these in. You get instant scale. If you want real-time applications, use PubNub. He's going to be talking a little bit. Amazing technologies where you don't have to own or know anything about the infrastructure. That's composable. And then Workload Aware. This is a fascinating one. If you want the system to be healthy and automatically respond to all the other elements of Serverless Manifesto, then it needs to be workload aware. For example, if you're processing an image, you may need a lot of CPU capacity. If you're doing an encryption algorithm, you may need a lot of memory to buffer this thing in so that you can do the encryption algorithm. But the system needs to be aware of what that workload looks like in order to move it to the proper infrastructure to do that. The reason is because if the developers today have a very keen awareness of everything that their application does. Something goes wrong, servers start crashing, DevOps or Ops calls the developers, yells at them, developers yells at Ops, and someone gives it more memory, and we're all happy. That coupling of those two teams is because the developers have to be keenly aware of these workload properties. So if we can move away from that, if we can shift the thinking into the system so that it can almost be self-healing, that's the concept of workload aware. Okay, so the future is serverless. If I've convinced you, great. If not, I'm going to pretend like I'm going to make some predictions here. A couple predictions. Compute will continue to commoditize. We're seeing this now, right? It almost doesn't matter where we get compute. Amazon is the absolute gorilla in the market, but there are tons of absolutely great players out there with special reasons why you'd use their infrastructure. It doesn't really matter. There's public and private clouds. It's being commoditized. We want to provide that layer. Serverless architecture will start to see some standards because getting to these architectures, and with microservices, we are starting to see some standards. So we'll continue to see these with serverless. The abstraction will continue to move up. If you think about how I opened the talk, our children are learning differently. They're going to expect to build software differently. The cognitive overhead of having to build and deal with infrastructure is just too high now. I mean, think about your children. They barely know. I mean, I'm surprised they're using grep, but they barely know what the hardware is now. Why would they want to program it? What's that? Yeah. They don't know what's going on behind the scenes. Why do they want to deal with it? So that is changing. I think we're going to see something around the algorithm economy. This is almost like an extension of the SOA or the next generation SOA, service-oriented architecture where we're going to be pulling algorithms from certain sites. There's Algorithmia, there's other ones. Iron.io's got some algorithms that we make available on top of our platform. But we're going to start to see a way to consume these things very easily just using REST calls and HTTP and encrypting them on the fly. And then I hope to see more specs from the container initiative. So we'll start to see more standards around containers. But containers really have so much power to them in that abstraction layer of being able to ship software a standard way. Because you want to be able to write software and just put it into the system. It should be run through CI. It should run through CD. It should be shipped. It should be in production. It should run on your laptop. It should run the same everywhere. That's the promise of containers. So you heard them here first. They're on tape, so we'll see where it goes. And then I'm going to end with an architecture. This architecture is pretty standard these days. It's generally what you see for load balancing. You've got some basic corporate infrastructure here. You've got mail servers and web servers and SQL servers and database servers and DNS servers. And as you've seen, you may have not even noticed, but we're starting to pull each of these pieces away. And even the applications now that run on these web servers and these application servers and these database clusters, everything is being pulled out into its own service. If you stored something on S3, it was Amazon's first service. Store something on Dropbox or Box, it's a service. It's all based on a service. So I'm not trying to hype AWS, but this was an architecture that they talk about. This is what it looks like today. You've got Gateway, you've got Lambda, you've got DynamoDB, you've got devices, you've got CloudWatch, everything in the service. You've got Iron.io, you've got PubNub. Take a look at those. But this is what it looks like today. Do you see what's missing? Obviously, we're missing servers, and we're not even thinking about them. So these are the architectures that we're moving towards. And I think due to the evolution, this is where we're seeing the world go, and there's going to be demand for it. So that's why I thought this would be an interesting extension of the microservices talk. That's it. Thanks.